today I am going to explain one small concept which is there in 11th standard, classification of elements in periodic properties. Under periodic properties I am going to cover electronegativity. So what is electronegativity? What is the trend of electronegativity in case of periods and groups, and what is applications of electronegativity? That all things I am going to cover in this video. If you like my videos, please subscribe, like, share and comment. Please support. Thank you. So I am going to explain here electronegativity, the concept of electronegativity. Concept is introduced by in 1932. Pauling introduced this concept. Pauling introduced this electronegativity concept. What is definition of electronegativity? For example, in between A and B, a bond is formed in between A and B. So to form a bond, we need two electrons. To form a bond, we need two electrons. If these two electrons are attracted by this B, so in such case we can say that B is more electronegative. So if this A is attracting electrons towards itself, then we can say that A is more electronegative. So based on this example, what we can say that, so tendency of attracting electrons, towards itself is called electronegativity. So this is the definition of electronegativity. Here Pauling given one arbitrary value for fluorine. So he took fluorine electronegativity value is 4.0. First he fixed the value of fluorine electronegativity is 4.0. Based on that he given electronegativity values of other elements. So the formula Xa minus Xb is equal to 0.208 into E of bonding dissociation enthalpy of EAB minus 1 by 2 into bonding dissociation enthalpy of AA plus BB all to the power of 1 by 2. So this is formula regarding electronegativity. Here what is meant by Xa and Xb? Xa stands for electronegativity of A, Xb stands for electronegativity of B. Here 0.208 is a constant. Here EAB stands for energy required to break the bond EAB, that is nothing but bond dissociation enthalpy. Here AA is nothing but bonding dissociation enthalpy of AA. Here bonding dissociation enthalpy of BB or bond dissociation enthalpy of BB, right? So by using this formula we can calculate electronegativity of any element, right? After this, electronegativity is average of ionization potential and electron affinity. So here they observed that Mulliken values are 2.8 times greater comparing with Pauling values. So then how can we express this in Pauling? So with respect to Pauling value, if you convert this formula into Pauling, then ionization potential plus electron affinity into 2 into 2.8 will come. Why? Because Pauling is 2 times greater, means this is what 2 times less, so that's why we are taking here 2.8. so then both will be equal. So if you are taking this ionization potential and electron affinity value, in kilocalories, then the value will be like this. So ionization potential plus electron affinity upon 2 into 2.8 into 23.6, 2 into 2.8 into 23.6. So if you are expressing ionization potential value and electron affinity value in kilojoules per mole, in such case ionization potential plus electron affinity upon 540, electron affinity by 540 will come. So to calculate electron affinity we can use this formula as well as this formula. This formula we have to use in which case if you are expressing ionization potential and electron affinity value in kilocalories, then we have to use this formula. So if you are expressing ionization potential and electron affinity value in kilojoule per mole, in such case we have to use this formula. Trend of electronegativity. What is trend of electronegativity in case of groups and periods in a periodic table? So in periodic table, so horizontal lines are called periods, horizontal lines are called periods and vertical lines are called groups. We know that already, right? So in a periods from left to right, in a periods from left to right, when we are approaching in a period from left to right, then electronegativity value will increase. Electronegativity value increase. Why? Because atomic radius will decrease. Atomic radius will decrease. When we are approaching in a period left to right, atomic radius value will decrease. When atomic radius decrease, then nucleus strength will increase. When we are approaching in a period from left to right, nucleus strength will increase. When nucleus strength increase, atomic radius will decrease. When atomic radius will decrease, then obviously electronegativity value will increase, because nucleus strength increase. Nucleus only will attract valence electrons, so that's why electronegativity will be increase in case of periods. So when we are approaching in a groups from top to bottom, when we are approaching a group from top to bottom, then when we are approaching a group from top to bottom, so differentiating electron means last electron. Differentiating electron means last electron will enters into new principal quantum number. Will enters into new principal quantum number. New principal quantum number. New principal quantum number. So because of that, new principal quantum number, because of that atomic radius will increase. Atomic radius will increase. When atomic radius increase, nucleus may not attract valence electrons that much effectively. Because of that, so electronegativity value will be decreased. In a group, electronegativity value will decrease. In a period, electronegativity value will increase. So this is a trend with respect to electronegativity in case of groups and periods. Factors affecting electronegativity. Which factors will influence electronegativity, that I am going to explain now. So first one is atomic radius, right? Just now I told you the trend of atomic radius. When atomic radius increase, then obviously electronegativity value will be decrease. When atomic radius decrease, electronegativity value will be increased. So that electronegativity is inversely proportional to what? Atomic radius we can take here. So next factor which will influence atomic radius is nucleus strength. So here, when nucleus strength increase, who will attract electrons? Actually nucleus only will attract. So this electronegativity value is directly proportional to nucleus strength. If nucleus strength increase, then electronegativity also increase. And third point, this electronegativity value, electronegativity value is constant, but it will influence by some factors. So in that, first one is hybridization. How the hybridization will influence electronegativity? Here you see sp hybridization, sp2 hybridization and sp3 hybridization I am taking. So electronegativity order will be like this. Why? Because in case of sp hybridization, s percentage is 50 and p percentage also 50. In case of this one, s percentage is 33.3 and p percentage 66.6. So in case of this one, s percentage is 25 and p percentage is 75 here. S percentage is 25, p percentage is 75. Where s percentage increase, then electronegativity also increase. Why? Because s orbital is very close to the nucleus, so that's why electronegativity order will be like this. So next one, charge on atom, or we can say oxidation number, right? So when charge increase, then electronegativity value also increase. For example, in between Fe+2 and Fe+3, where electronegativity is maximum means in case of this one electronegativity is maximum. When charge increases, electronegativity value also increases. So here some important points to remember towards this electronegativity. So most electronegative element in a periodic table, most electronegative element is fluorine, which value is 4.0. Then after, oxygen is a second more electronegative element. Oxygen is second more electronegative element. So electropositive element means less electronegative element is cesium. Less electronegative element is cesium. And second point, D black elements electronegativity values. D black element varies from 1.34 to 2.6. D black elements values will varies from 1.34 to 2.6. And F black elements, lanthanides electronegativity values, lanthanide electronegativity values varies from 1 to 1.3. These are D black elements electronegativity values, and these are F black elements electronegativity values. And which is having more electronegativity, that is metal, that is non-metal. And which one is having less electronegativity, that is metal, right? So next one, importance of electronegativity. By using electronegativity, what we can predict, right? So by using electronegativity, we can predict whether it is 100% ionic compound or 100% covalent compound, and what is the percentage of ionic compound, and what is the percentage of ionic nature, and what is the percentage of covalent nature. These all things we can predict by using electronegativity. Mainly we can predict the nature of the bond here. Clear? For example, in between two elements, A is there and B is there, in between these two elements, if electronegativity difference is 0, that is 100% covalent bond, 100% covalent bond. Why? Because here you see hydrogen, chlorine, right, bromine bond. Hydrogen, chlorine, bromine, these all will form covalent bond. So next one, if in between XA and XB, XA means electronegativity difference. Electronegativity difference is very less. In such case, this bond is polar covalent. This is second point. And third point, if the electronegativity difference between XA and XB is 1.9, if electronegativity difference is XA and XB is 1.9, then 50% covalent and 50% ionic. Actually this value is different in different books. I am following here OP Tandon book, so that's why I am giving this book from OP Tandon textbook. This is reference from OP Tandon. So next one, we can calculate the exact percentage of ionic percentage by using this formula. So 16 into XA minus XB, 16 into percentage of ionic bond, percentage of ionic nature, 16 into XA minus XB plus 3.5 into XA minus XB whole square. So by using this formula, we can predict percentage of ionic nature. So here XA and XB stands for electronegativities of A and B elements. So